Hello everyone. I wanted to discuss the C2 problem of Code Forces round 977. The problem name is Adjust the Presentation, the hard version. If you haven't read the problem statement, I would request you to do so. I won't go much into the problem statement, so I will jump to the test cases instead. We are given two arrays A and B. A is the arrangement of people, and B is which person will present the slide, which slide. So in this example, A is 1, 2, 3, 4. So the person 1 is in the first, then followed by second, second is followed by third, third is followed by fourth, and slide 1 is to be presented by person 1, slide 2 by person 2. In this test case, slide 1 by P1, slide 2 by P2, slide 2 by P1, then slide 3 by P2, 4 and 5 by P3, and 6 by P2 also. And in this example, the arrangement of people changed. So now the third person is standing in the front, followed by one, then four, then two. And here slide is also like first three will present, then one will present, then two will present, then three will again present, and then four will present. So I hope you understand the problem. Now we are also given two queries of the form I comma k, and we have to set the ith presentation to be 2. So basically the ith presentation will now be presented by the person number 2 or the person number k. Then so this is the problem. Now so one thing that we can see is we can easily make the we can easily ease out the order of people. What I mean by that is we can label AI to be I. What it does is it eases out the implementation and thought process for us. And why is that? It is because if we map or label 3 as 1, we can simply label 3 as 1 in B as well. So that does not change our problem. And subsequently in the queries as well, we can label like this 4 can be labeled whatever we have mapped it to. So in this example, 4 will be mapped to 3. So subsequently we can map every occurrences of like whatever the person is. So that is what can help us in this. So that is the first step towards the solution. So if it was not clear, I will reiterate it again. We can simply put labels of 1, 2, 3, 4. So every question will we can think in that angle. We don't have to think about the arrangement of people. We can ease that out by labeling AI as equal to I, and then again mapping these subsequent like people tag in the array B and queries as well. So if I have to give an example, what I mean is I'll say this is 1, this is 2, this is 3, this is 4, and I can store that in a map of what maps to what. And so here as well, when I mapped this as 3 to 1, then this array will also, here it will be 1, it will be 1 here as well. Here it will be 2 and 2. Here it will be 3 and here it will be 4. So now let's move to the next step of the solution, which is we have to think uh, how, now that we are given a array B after we have mapped. So I hope the mapping step is clear. It will ease out our procedure, because now we just have to think about the order of the slides. We don't have to worry about order of people, because they will be 1, 2, 3, 4 till n, and we can change the ordering of slides according to that, and obviously subsequent queries as well. So now the main thing that we have to check is if we can achieve the slide ordering. If we can, we have to print yeah, and if we cannot, we have to print TDAC. So in the first example, we can see that the first person can present the slide 1 and 2 as well. Now, the one thing to notice in this, one observation to make is whenever a person is complete with his presentation, then the subsequent occurrence of that person can always be achieved. So, what I mean to say is if a person, AI, is done presenting slide, let's say BJ, then if BK, if BK is equal to AI and K is greater than J, then it is always possible. Now, why I am saying this is because let us take an example for 1, 2, 3, 4, and this is A, and now let's say the P is 1, 1, 2, 1, and then 1, 2, 3, 1, and then 1, 2, 3, 4, 1. Once 1 is done presenting, what I can see is, can 1 present again? Yes, if 1 is done presenting, it can present here. Like obviously 1 won't move, but now as soon as 2 comes, 1 has to be moved somewhere. But we don't immediately have to move 1. What we can say is let 2 present. So 2 has presented. Now it could have been 3, but it could also have been 1. So that is where our idea of not moving 1 immediately comes handy. So if this was 3, I could have said let's move it behind 3. So let's understand this with the help of these three examples. So 1 could have been moved here in this. So this is possible. Now 1 could also have been moved here. So this is also possible, and 1 can also have been moved, could have also have been moved here. So this is also possible. So what I'm saying is, after a person is done presenting their slides, they can come back anytime afterwards. So we are just um, we are just concerned with the first occurrence of a person. So I hope that is clear. So now there is also another observation. The first observation is that only first occurrence of a person matters, because afterwards they can present freely, like as shown in this example. And then another observation is that once, uh, so in this ordering 1, 2, 3, 4, could this have been possible? 1, 3, 4? No. And that is because in the line 2 was standing before 3. So 3 can never present before 2. Now this is possible. Why? Because now you can say that 3 is presenting before 2, but no. 2 has already presented, and now 2 can come anytime to present. So the first time a person presents has to be before the first time a person behind him presents. So basically, what the observation is that first time. Now, since we also did this mapping, so if the person is P, then the next person will always be P plus 1, because we have done this mapping here. So the first time P presents has to be smaller than the first time P plus 1 presents. I hope that is intuitively, like that is very intuitive to you, because a person standing in front of another person uh, won't be able to present after him. So if a person is standing uh, before in a queue, then the first time he presents has to be before the first time that the person behind him presents. I hope that is clear. So now this is another observation. So let's take this example. Let's take the example here and try to solve it. So since this is already 1, 2, 3, I won't be doing the mapping step, but let's check this 1, 1, 2, 3, 3, 2. So this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. So let's say that I note the first occurrence of I in the first I, this array. So okay, so I won't be till there. I will just be till 3. So here, the first occurrence of 1 is at the index 1. First occurrence of 2 is in the index 3. And the first occurrence of 3 is in the index 4. So if this array is sorted according to this observation, then we can just print yeah. If it is not sorted, we can just print didac. So um, this is again I'm repeating myself that if the first time a person presents is earlier than the first time is before than the first time a person behind it presents, then we are good, because we are okay, because intuitively and logically as well, a person standing first in the line will get to present first, otherwise it won't be possible. So that is what we have to check. And what we can do to efficiently check this is, what I did was I maintained a set of indices. And so the set contains, so here as you can see, I have 1, 2, 3. I have 3 indices. I just check if first of I is smaller than equal to first of I plus 1, then there is a match, and uh, this index does not have to be in this set. This index won't be in this set. And if this is the case, if the case is this, that the first of I is greater than first of I plus 1, then I has to be in the smaller index has to be in the set. So if the set is empty, we can just say that this array is sorted, because uh, this is this is basically what it means, that the set does not have any index, so that set is sorted. If this is not the case, then we can say that the set is not sorted. So now here what we simply have to do is, in order to update this set, what we can say is we can just create a collection of a vector, let's say, of sets. And this will, so this, let's say this is v, then v of I will have all the indexes of all indices of I in b. So like for example, v of 1 will contain 1, 2. V of 2 will contain 3, 6. V of 3 will contain 4 and 5. So like that is what we can do. And also, let's say if the so if some person is not present, we can just say that the index of that so let's say if 3 was not present at all here, we could have said that the first of 3 is, let's say, m plus 1, because yeah, it's not present, so let's assume that it is present in the m plus 1. And this will help us, as we will see later. So um now, when we are trying to update, we just have to check whether the updated index is of this, like if the updated index is following this. So let's say the ith index is, just write it down. So if the ith index is changed in first, then we can just say if the first of I is this, and first of I minus 1 is this. If this is true, we have to make sure I should not be present in the set. If this is true, we have to make sure I minus 1 should not be present in the set. Like I said, we have to just check for the lower index. And if this is false, we have to insert this in the set. So now in the end, we can just check if the set is empty. Answer is yes. If the set is not empty, answer is no. So let's try run this example. Uh, okay, here. Let's try run this example with this approach now. So mapping is already here. The people order is 1, 2, 3. So mapping step can be. I won't illustrate the mapping step, but now I'll just check. I'll just say what is V. So V of 1 will be having the indices 1 and 2. V of 2 will be having the indices 3 and 6, and V of 3 will be having the indices 4 and 5. Okay, and first of I will just basically first of I, as you can see here, is nothing but V dot begin, or the smallest element in this V. So V of I dot begin, sorry. So basically first array will be 1, 3, 4. And now here the set initially, which is this set, will be of size 0. This will be an empty set. Why? Because every index follows this property. So we can just say yeah in the first go. Now after the first query, which is of this nature 3, 3, what we can do is we can remove the so what we can do is we can change whatever was in the third place. I can, so 1, 2, 3, 4, 5, 6. So in the third there was 2. So what I can do is I can check what was in the third, and I can remove this from there. So B of 3 was 2. So what I can do is I can remove. So now 2 was at the third position. So I can remove this 3 from this set. And here I am updating it to 3. So now I'm saying that at the third index, 3 is present. So 3 is also at the third index. So I can put 3 here in the set of 3. And accordingly, I will have to change the first. So now, since I have said that 2 has been removed from the third index, I should update 2 and the first. So I updated 2 by removing it, and the first will also change. So the first of it will become again v dot begin. So it will be 6. And now since 3 also has been updated, and we can check that the first will also change here. So the first is also changed. Now set will set will also change, because now this index follows the our follows our convention, but this 2 index does not, because this is so the set will have uh, 2 2 in it. Now since the set is not empty, what we can say is that this is also not possible. And again, when we have set 2 to be equal to 2, so now we are saying that make it equal to 2. So whatever was on the second index, so second index had 1. So what I can say is 1 was on the second index, but now we are removing 1. So what I'll say, please remove the index 2 from 1, because it is no more there. and now I'm saying please add 2 to it. So what will happen is I just say please add the index 2 on 2 because 2 has been added. So I will update 1 and 2. 1 will be updated to v dot begin, which is 1, so it will remain the same, and 2 will be again updated to v of 2 dot begin, which is 2. So this will be now this, and now you can see that this array is sorted again. So 2 will also be removed. And like to check that, we just have to, so 1 can be checked by, so here 2 is changed, so we can just check if this is fine. So this is fine, so I can just check if 1 was present in the set, remove it. 1 was not present, so I didn't remove. And now here 2 is present in the set or not. 2 was present, and but this followed, so I removed 2 as well. So I guess the last thing might not be clear, so I'll repeat it again, um, and hope that this time it becomes clear. When we are updating, when updating element or like person I, then we just have to check I minus 1 and I in first, and I plus 1 in first. If they follow the order, which is this, please remove the lower index from the set. If they don't follow, please add the lower index from the set. Similarly here. So now let's move on to the code, and I will explain the code line by line so it will be easy to follow. So this is my submission here. This is the input, and I'm just taking a MP map, which will basically what I said about the mapping part. Now this is what V was. Basically, V here, this V is position in my code. So it's a collection of positions. So basically, I'm iterating over the B array, and I'm just this MP basically means that this is like basically the, like obviously the mapping here means MP. So I'm just saying that the position of this person is in the array B, and then I'm inserting it in the set. And also I'm inserting m plus 1 in every set. And why I'm doing that is because a set can be empty, and just like I said, if the set is empty, we can just insert the highest value in it. And so afterwards basically, if let's say 2 is missing and 3 is there, so there will always be a something, there will always be a violation inserted in the set. So that is why if let's say 2 is not present in the presentation order, then 3 can also not be present. Now, so here first is of size n plus 2 is because uh, it would be easier for me to basically this is an exam implementation to ease implementation, because it will be easier for me to check I minus 1 and I, and then I and I plus 1. That is why, like if I was 1, I could just check 0, and if I was n, I could just check n plus 1. That is the simple reason why I made first as n plus 2. Now I'm making first of n plus 1 as n plus 1 again, because I want, so I keep first of 0 to be 0, and first of n plus 1 to be n plus 1, because this will always be true, this will always be true. Now here you can say I'm constructing first. It is basically position dot begin, and then result is a set, that set in which violations are contained. And if the size of result is something, then I should output TDAC, otherwise I should output YAC. Yeah. And the update function is basically I'm updating the first of k, and it will become the position of k dot begin, and then I'm just taking k minus 1 k, and then k and k plus 1. And if it is true, then I should erase. If it is not true, I should insert, like in both cases as I told. And now here I'm handling queries. I'm K1 is basically what was in the map. So K1 is basically what was present before, and K2 is what is present after. So here I'm just setting BISK, and then I'm again, like I told, I should erase what was present before and I should insert what was present after, updating both, and then checking if result.size is something. It should be TDAG, and if results is empty, then obviously all indexes are following the condition, and that's how the code is. I hope everything is clear in the solution, and if it wasn't, then please you can come back to this code and again read the code. There is not much in it, so yeah. Thank you.